the point here is when I move this wire, this is the base bias resistor, and I've got a resistor network here that's each increment is 10K, and if you watch these, 10K doesn't really do much. So I've got it all the way. That's adding 50K, and there is a difference here if you caught it. I have a resistor network here, and each increment is 10K, and it turns out that with this bias resistance to the first transistor, 10K doesn't do much, so I'm going to jump the whole 50K. And then you can see this changed. A change here, a change there. What else I've done on this circuit is I've added another transistor, which is a PNP in the CC. Common collector PNP. And this is a load resistor, which is half of the emitter resistor. The power comes off the emitter transistor junction when you're using a common collector circuit. With a common collector you don't get a lot of voltage, but with this circuit I am making it it's a DC current amplifier. IE here isn't a great advantage to what it was before, but I think when I get I'm going to have to do some calculations to show that the output resistance is lower by another dimension. And here is the voltage at the emitter, which is like a quiescent DC voltage point, so it's halfway between the 12 volts and ground, which is what we want to keep through this whole thing. Here I've changed this. What I'm measuring here is the current coming out of this one going to ground. It's 40.0. That would be the current going through the load resistor, which is roughly half of the value of RE here. Well, here's the circuit diagram that I've worked up for this. Down in the right hand corner where it says RL, that means microamps.